Check one. Check one. Right. Hello, everybody. Today, we are starting totally a new set of program for grade 11s. That is the 2025 O level batch. Already 24 batch. They are on their they are doing that. So we are starting a new program for that is interactive class. Even for last batch, we were doing interactive class, which falls on Saturday night. The time is from 8 o'clock. This time slot 8 o'clock to 10:30, 8 to 10:30, 2.5 hours. What is special about the interactive class is it's not like the normal online class. Here, y'all are allowed to unmute, y'all are allowed to ask questions, right? It's kind of more discussion like session. That's how online interactive class goes there. Okay. Before we start, confirm me from your end. Is all the DOs perfect? Video, audio? Now, today still I didn't allow you all to unmute because first day, free day, initially you all should get used to it. Then I'll slowly allow you all to unmute. First send me the message. All okay? YouTube, I kept the YouTube chat box on. Zoom okay. YouTube also okay. Right. Perfect. Yeah. Hurry. Hurry. Right. Now, until now, our normal online class was we did a live stream of our candy class. That was a normal online class. So from today onwards, you'll be getting two options. Either you can continuously join the candy online live stream, candy live stream, candy live stream, which falls on Sunday tomorrow, 10 a.m. to 12:30 p.m. That is live stream of the physical class. Live stream of the physical class. That's the live stream of physical class. Other than that, we are starting the interactive class. Interactive class is today's one. Interactive class is today's one. It is Saturday. It is Saturday, 8 p.m. to 10:30 p.m. So you can online people, you can join any one of that and you can continue your session and let us select one of that and then you can continue to do one of that until your exam. Until your exam. That's how it is going to proceed. Okay. Now already your previous batch have finished their O-level exam. Right? Papers also got released. Essay structured when we ask the essay structured essay pattam easy. If you go through the MCQ essay structured essay, there is nothing to speak about it. Sometimes we have to ask a question, is it a paper? Such a essay paper is given, structured essay we couldn't see, but according to the comments from students about structured essay and according to I got the essay paper, when we look at the essay paper and all, we sometimes feel, is it a paper? එහෙමත් හිතෙනවා ළමයි. Such a lot of work is done. And sometimes we feel unhappy also. Because after doing such a lot of work, giving such a paper in the final low level exam, such a paper was there for essay. But MCQ, such a standard paper was given. I'll talk to the previous batch, let them first finish their exam. MCQ paper, it's a very good standard paper. The main reason is maybe because last year's paper, there were so many issues. Even when we were discussing last year's paper, there were so many questions that were given free marks. In the this time, MCQ paper, such a standard paper, about 4 questions are there, totally logic. You have to apply more logics to do that question. Other than that, I think more lazy thing. MCQ also, there is no such hard thing other than those 4 main questions. Other than that, not hard, but first question is totally different. First question in MCQ paper is totally different. So once when you do the first question, it becomes different. Totally different style. So once when you do the first question, some students go off the mind. Sometimes students decide, no, paper is hard. No, it's not like that. First question is given in a total different way. You can't expect all the questions to come from the textbook. I have always told you, even for your batch, you can't expect always the questions to come from the textbook. Science can anything. In science, guaranteed you can't expect everything to be coming from the textbook. There will be some places where you need to use your logic and understand, do the question. So such a question was given the first question. Other than that, MCQ also nothing to speak. Right? Nothing to speak. Such a question. Let them finish their paper, all the exams. After they finish their all exam, I will release the marking scheme as well. In case if any previous batch students are watching, I'll release the marking scheme for them as well. But first you all finish the paper. Now still you all are in your exams. No? First you all finish the exam. That is for them. So their batch is now fully over. Their batch is now fully over. Their exams also. Everything is over. Next is your turn. Now y'all are the batch. And that word comes to you. Y'all are the batch. I have already told this at the beginning of all my classes. Now, still you can't be playful. Now it's the time for y'all to work. Get into the work. Still don't wait until the correct time comes. There is no time called correct time will come. Now it's the time. Already 10, grade 10, already 20 lessons are there for you to complete. In case if you have not touched it properly, maybe in the exam, during the exam, or during the week before the exam, you would have touched those lessons, but you never touched that lesson properly for your final exam. So now it's the time to cover the lesson. Most of you are in your free time now, or off season. Most of you are having your school holidays, and some of you, those who have the school, also no much exams there. In the most of you are in your off season now. So those are in your off season. Start finishing the grade 10 section for now. For now, start finishing the grade 10 section. 20 lessons are there for us to complete from the grade 10 section. And start doing the past papers as well. If you don't have a past paper book, I think still don't tell you don't have a past paper book. Start doing the past paper books as well. Already about 55% of the past paper question you can fully finish off. In the start doing the past papers as well. Once then you come to a certain level, then I will give my maximum support from my end. If you have followed up for the previous batch, you would have seen how much of work is done for their batch. Double that work is already planned for your batch. Already planned, double that work. Every year I'll do at least double the work I do for the previous batch. Already double that work is planned for y'all. What I need is from your end, I need the fullest input. That's it. Sorry. Those are the things I wanted to tell. Without talking anything further, we'll start the lesson. Already mixtures lesson, until mixtures lesson we did in our normal Sunday online class. Have a mixtures are a separation, uses of separation technique. Last part is remaining. Salt extraction, very tiny part is remaining for us. So if there are any student who usually joins our Sunday class, see that tomorrow's class, for the first half an hour you all join. After that, if you are continuing Sunday class, you can join. Otherwise, you don't need to join Sunday class. If you are joining Saturday class, you can continue with Saturday class. So tomorrow, small half an hour part you all join. Small part is there for us in mixtures to finish off. After mixtures, our fourth lesson is waves and their applications. Waves and their applications. What the important lesson, ne? Waves and their application. Unit number 4. Unit number 4. Totally different physics lesson. Until now, the physics you have learned and the physics that you learn in waves and their application is totally different. Such a different physics lesson. Now, 6 years of science, you have never touched about waves. This is the first and last wave lesson you will be learning in your O-level journey. So totally different, new, but very important section. So from beginning until the end, listen very, very carefully. I hope all of you already you all have the tute with you all. I have sent it to the WhatsApp group. If you don't have the printed tute, at least have the PDF with you. Additionally, have a writing book or a short notebook nearby. So in case if I give any additional points, you all can write it in that additional book. First, get ready with those stuffs. Get ready with the additional book or some papers for now. And meanwhile, confirm me, is there any problem with the video? No. Really live streaming, no? So from your end, get ready with your book or whatever you all needed. And send me ready from your end. Ready. Perfect. All okay, no? Hurry. Now sit properly. This 2.5 hours, don't make it a waste. You all listen very carefully. There is no time to again learn it separately. You sit now, you learn now. Now you put it to the mind, and then you finish off. You don't have anything in your mind such that you can learn it separately. You can take some more time separately and don't put such an idea into your mind. Your one and only idea is this is the only time you are learning. At this time, you put the things into the mind and you finish off. on waves and their application. Listen very, very carefully. Huh? What is wave? What is wave? Listen very carefully. What is wave? First, I'll tell the definition, then I will explain. What is wave? A wave is a disturbance. A wave is a disturbance that propagates energy from one place to another place. Again, what is a wave? Wave is a disturbance. What does it do? Propagate energy from one place to another place. Now, everything together. What is a wave? A wave is a disturbance that propagates energy from one place to another. Where open the mouth and tell louder. What is wave? Wave is a disturbance that propagates energy from one place to another. That means, now for example, when I am talking. Now King Saya is talking. When I talk, I am producing sound. Sound is a energy. Sound is a energy. How this sound energy travels from me to that corner? How that sound energy travels from me to that corner? By producing or by making sound waves. It makes sound wave. So basically, the wave they are is only carrying the energy. What energy? Sound energy from here to there. And now see, when I talk, what I am doing? I have some air particles here. When I talk, I am disturbing those air particles. I am creating a vibration in those air particles. I am moving those air particles front and back. Later I'll teach it. There are compressions and rarefaction. Later I'll teach. I am disturbing the air particles here. Now see, air is very calm and quiet. When I talk, air particles are disturbed. So I'm making a disturbance. That disturbance is only propagating the energy. So that's why we tell a wave is a disturbance that propagates energy from one place to another. One more time, open the mouth and tell louder, louder. Wave, what is a wave? A wave is a disturbance that propagates energy from one place to another. Again, one more time. What is a wave? A wave is a disturbance that propagates energy from one place to another. On one important point, one very important point. Yes, wave will propagate the energy. It transfers the energy. It transfers the energy. It propagates the energy. But will it transfer particles? Does it transfer particles from one place to another? Now, when I'm talking, I talk, air particles are here. Does the air particle near me travel from me to that corner? No. That's a very important point. Remember, during wave motion, energy transfers from one place to another. Particles do not transfer. Particles do not propagate. Particles do not move totally from one place to another. When I talk, does the particles here carrying the sound and going all the way from here to there? Particles are not going. Particles doesn't show a total displacement. Particles are not totally moving. Only the energy is propagating. So during a wave motion, energy is transmitted, but particles does not totally move. Particles does not propagate. Particles does not displace. That's a very important. Okay, understood. Yes. I'll check the YouTube chat also. Clear. Clear. Yes, 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 yes. Perfect. Take the tute now. In case if you don't have the tute, don't just wait. You'll at least have the PDF with you all. Take a I told you all to take a writing book or a paper. Whatever I tell you to write, you write it in that paper and keep. So at least later you can print it out and you can complete the tute. Waves and their applications. What is a wave? Under that, we'll write down. What is a wave? Let's write down. A wave is a wave is a wave is a wave is a disturbance 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 that propagates energy that propagates energy that propagates energy from one place to another. From one place to another. From one place to another. So can we write it as transmit energy? Yes, no problem. Those are synonyms, no? You can write it. Propagate energy from one place to another. Now under that point is also given, Lamai. That point is given. Waves propagate energy from one place to another without the propagation of particles. Energy will propagate, particles do not propagate. Underline or highlight? Underline or highlight? Right. Now, again, on the screen, yes, on the speaker, listen very, very carefully. On wave. What is a wave? Wave is a disturbance. Propagates energy from one place to another. Lamai, waves are divided mainly into two types. Wave divided mainly into two. Wave divided mainly into two. What are the two? One, mechanical wave, and two, electromagnetic wave. Open the mouth and tell what are the two types of waves? Mechanical wave, electromagnetic wave. Again louder. Mechanical wave, electromagnetic wave. Again, mechanical wave, electromagnetic wave. Mechanical wave. What is this mechanical wave? The mechanical wave requires a medium to propagate. Mechanical wave requires a medium to propagate. It needs a medium to propagate. Without a medium, mechanical wave cannot propagate. It needs a medium. Medium means Single medium, Tamil medium, English medium, that medium. No, not that medium. Medium means a substance. Substance that has particles in it. Solid medium, liquid medium, gas medium, those are mediums. So mechanical wave needs a certain medium to propagate. Either it needs solid medium or liquid medium or gas medium, some kind of a medium is needed. Without a medium, it can't propagate. Without a medium means in space. Do we have any medium in space? No. Can mechanical wave propagate in space then? So remember, mechanical waves need a medium. It requires a medium to propagate. Without medium, it can't propagate. Opposite is electromagnetic wave. Opposite is electromagnetic wave. Think. Mechanical wave, medium. Then electromagnetic wave, do not require a medium. Do not require a medium. It do not require a medium to propagate. This do not require and require, those words have a deep meaning. Do not require a medium. What do you mean by do not require a medium? Medium is not a requirement. That means electromagnetic waves can propagate if there is no medium. Yes, do not require a medium. If there is no medium, it can propagate. As well as if there is a medium, still electromagnetic waves can propagate. If there is no medium also, electromagnetic waves can propagate. If there is a medium also, electromagnetic waves can propagate. That is what you mean by do not require a medium. Medium is not a requirement. If to be more specific, I'll give an example. 2037. Your exams are all over. All exams are, everything is over. Now you all are working. What is it? Now you all are working. You are going for a job interview. All your studies, further studies, higher studies, everything is over. Now you all are going for a job interview. In the interview, they have mentioned A for science in O-level exam is required. A for science in O-level exam is required. It's mentioned in the job interview propaganda. What does that mean? Only those who have A for science can attend that interview. Those who don't have A for science, can they attend that interview? A for science is required. That means only those who have A for science can attend. Another job interview is there. Let's say there they are mentioning A for science is not required. A for science is not required. What does that mean? Those who don't have A for science can attend the meeting, attend the interview, as well as those who have A for science also can attend. That's what you mean by A for science is not required. They don't check that. It's not required. Those who have A for science also can attend. Those who don't have A for science also can attend. Same story here. Do not require a medium. Medium is not a requirement. So if there is no medium, electromagnetic waves can travel. Even if there is a medium, electromagnetic waves can travel. That point is very important. Keep that in mind. So remember, mechanical wave require a medium to travel. Electromagnetic wave do not require a medium to travel. Medium is not a requirement. On next, mechanical wave. My mechanical waves are further divided into two. I'll draw it a bit bigger. Mechanical waves are further divided into two. What are the two? One, transverse wave. Open the mouth and tell. Transverse wave. Again louder. Transverse wave. New words. Open the mouth and tell louder. Transverse wave. Two, longitudinal wave. Longitudinal wave. What are the two types of mechanical waves? Transverse wave, longitudinal wave. Transverse wave, longitudinal wave. Both of them are mechanical wave. That means both of them require a medium. They both need a medium to travel. Without a medium, they can't travel. First, going to transverse wave. What is this transverse wave? Now look very carefully. Look very, very carefully. Transverse wave. Transverse wave is a mechanical wave. If it is a mechanical wave, it needs a medium to travel. Medium, solid medium, liquid medium, gaseous medium. Medium will have particles in it on. These are the particles. These are the particles in the medium. Now listen very, very carefully. Onnalamai transverse wave. Let's take transverse wave. Wave is traveling in this direction. That's the direction of motion of wave. Wave is traveling in this direction. When wave is traveling in this direction, particles are going to move up and down this way. Particles are going to move this way. This is the direction in which particles are moving. Now look at the direction of motion of the wave and direction of motion of the particles. Can you see direction of motion of the wave is perpendicular. Perpendicular, 90 degrees, perpendicular to the direction of motion of the particles. Wave is moving like that. Particles are moving perpendicular. Perpendicular means 90 degrees. Perpendicular to the direction of motion of the wave. And such a wave is transverse wave. Particles move perpendicular to the direction of motion of the wave. Particles are going to move perpendicular to the direction of motion of the wave. Transverse wave. Hari nilamai, it needs particles. If it needs particle, it needs a medium. That's why it is a mechanical wave. Transverse wave needs particles. If it needs particle, it requires a medium. If it requires a medium, it's a mechanical wave. Particles are going to propagate perpendicular to the direction of motion of the wave. So what's the keyword here? What's the keyword here? Perpendicular. Perpendicular. Particles motion is perpendicular to the direction of motion of. Again louder, tell me. What is wave? Particle motions are perpendicular to the direction of motion of the wave. Again louder. Particle motion is perpendicular to the direction of motion of the wave. Keyword perpendicular. What are the examples? You pluck a guitar string. Just think of the motion of the guitar string when you pluck it. I'll show it using some wires. When you pluck a guitar string, what is this? Guitar string. When you pluck it, can you see this guitar string? Particles are moving perpendicular to the direction of motion of the wave. Wave is traveling from here to there. Wave is traveling from here to there. But I pluck it this way. I pluck it this way. See? I pluck it this way. I pluck it this way. So I'm plucking the guitar string perpendicular to the direction of motion of the wave. If I draw and show, if this is your guitar string, I pluck the string this way. This way I pluck it. Wave is going to travel from here to that corner. I pluck this way, wave travels this way, perpendicular. Now, do we ever pluck the guitar string like this? Mihima, do we pluck it? Think, do we pluck the guitar string this way? No. Guitar string is plucked this way, not this way. Right? Perpendicular. Guitar string is plucked perpendicular. All the string instruments, guitar, violin, all of them are plucked perpendicular. So motion of a plucked guitar string. Example, motion of a plucked guitar string. Another example, think of water waves. Water waves. Wave travels in one direction, water particles move up and down. Wave travels in one direction, water particles move up and down. Transverse wave. Water wave. That is transverse. Clear? Understood transverse wave section? Understood transverse wave section? Yes. Everyone. Perfect. YouTube? Yes. Now coming into longitudinal wave. Nothing big. The longitudinal wave is also a mechanical wave. If it is a mechanical wave, it needs a medium to propagate. If it needs a medium to propagate, guaranteed it will have particles. If it needs a medium to propagate, there will be particles in it. These are the particles. I'll not draw a lot of particles, only few particles I will draw. Let's take wave is traveling in this direction. This is the direction of the motion of the wave. Wave is traveling in that direction. Particles are going to move front and back this way. Particles move front and back that way. See? Particles move front and back. Particles move front and back. Now look at the direction of motion of particles and direction of motion of wave. What can you tell? Tell me a proper word for that. This and this. If particles are like this, wave is like that. What can you tell? Tell me a proper word. What kind of thing you see between both their motions? Parallel. And that's the key word. They are parallel. They are going to be parallel. That means direction of motion of the wave is parallel to the direction of motion of the particles. Particle motion and wave motion are parallel to each other. Particle motion and wave motion are parallel to each other. Here, particle motion and wave motion are perpendicular. Here, particle motion and wave motion are parallel. So understand the keyword. Here, perpendicular. Here, parallel. What's the example? What's the best example? Sound wave. Sound wave. Remember, sound wave is a longitudinal wave. Particles move front and back. Particles move front and back. Okay. So that's the summary point of this full lesson. And separately, we have to learn about electromagnetic wave. Again, one more time. Wave. What is a wave? A disturbance. What does it do? Propagate energy from one place to another. Wave divided into two. What are the two? Mechanical wave, electromagnetic wave. Louder. Mechanical wave, electromagnetic wave. What doesn't need a medium? What doesn't require a medium? Electromagnetic wave. What requires a medium? Mechanical wave. Mechanical wave further divided into two. Transverse wave, longitudinal wave. Transverse wave, what's the key word? Perpendicular. Longitudinal wave, what's the key word? What are the examples for transverse wave? Motion of a plucked string of a guitar, water wave. Longitudinal wave, sound wave. Now look. Onna sound wave, it's longitudinal wave, which means it's a mechanical wave. Sound wave is a longitudinal wave, which means it's a mechanical wave. Mechanical wave, do they require a medium? Mechanical wave require a medium. That means sound wave also requires a medium. Now tell me, if you go to space with your friend, you and your friend have gone to space, small trip to space. You and your friend have gone to the space. Let's say you are shouting at your friend. You're calling. Hey, look at me. Can that fellow hear? Let's say you don't have any transmitter or anything. Can that fellow hear? Ah, he can't hear. Why? Sound wave doesn't propagate in space. It needs a medium. It's a mechanical wave. That's why when astronauts go to space, they use special transmitters. Inside ISS, no problem. But if they are working outside ISS or if they are in a planetary mission, right, they have to use a special transmitter. In space, sound can't travel. Needs a medium to propagate. It needs a medium to propagate. Okay. Now one more question you'll be asking me. Sir, now in a wave motion, particles do not move. Neither. There's no total motion in the particle. But look at transverse wave. Particles are moving now. Look at longitudinal wave. Particles are moving now. No, Lamai. The idea is this. The real idea is this. Look at transverse wave. Wave is traveling from here to here. Hurry. Particles are moving up, down, and coming back to the original position. Particle move up, down, come back to the original position. Up, down, come back to the original position. Up, down, come back to the original position. If it is longitudinal wave, particle move front, back, come back to the original position. Front, back, come back to the original position. Here, up, down, come back to the original position. It's moving up, down, coming back to the original position. Then you all tell me, is there a total motion in the particle? Is the particle fully moving from one place to another? Is there a displacement in the particle? Even longitudinal wave consider. Particle is moving front, back, original position. Is there a total motion in the particle? No total displacement. Wave is traveling from here to there, wave is traveling. But particle is not traveling. Particle is just oscillating, going up and down around a fixed position. Oscillating around a fixed position. Its fixed position change. That's why particles do not propagate. Particle will show, maybe it will show some vibration, it will show some front back motion, but it won't fully move. There's no total motion in the particle. Okay. That's the full summary of this lesson actually. That's the full summary. If I make it very small, you will not be able to see. Tell me this size. Can you all see properly? That size? Yes. 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 Right. Now, in the tube, the box given. That box is for us to write that summary. Write that summary. Use some nice color pens, nicely write on this particle motion and all. Use some color pens and nicely draw it. Once done, tell me done. Some have done. Done. How can I get the PDF? Uh, I hope you have joined the WhatsApp. I have sent to the WhatsApp group, Puta. Shall I forward it again to the WhatsApp group? Okay, I'll forward it again to the WhatsApp group. Yes, maybe some people have joined today in the evening. Those people would have not seen the PDF. I have again forwarded the PDF. Okay. Done. You know. Perfect. Right. So that's the full summary of our lesson. Now going section by section. First going to mechanical wave. You all know already. Mechanical wave. You all tell me, eh? Now I'll allow you all to unmute as well. Right. Sorry. Good evening all. Cool am I? Cool. Now you all tell me, eh? I don't know why it's not clear enough. Sorry. You all mechanical wave. What is mechanical wave? Needs a medium or don't need a medium?
Needs a medium.
Needs a medium.
Needs a medium.
It's a medium.
It's a medium. What are the examples for mechanical waves? I didn't give any examples.
Water wave.
What are the examples for mechanical waves?
Water wave.
Motion of a plucked guitar string.
Water wave, sound wave.
I didn't give an example for mechanical wave. Now y'all think. Y'all think. I didn't give an example for mechanical wave. Now what's the example for mechanical wave? Ane lamai. We know motion of a plucked guitar string, water wave, sound wave. These are all coming under mechanical wave. Motion of a plucked guitar string, water wave, sound wave, all are coming under mechanical wave. Then we can tell examples for mechanical waves are motion of a plucked guitar string, water wave, sound wave, all are examples. Write down the examples. Write down the examples. Motion of a plucked guitar string, water wave, sound wave, okay. All these three are examples. Hurry. Mechanical waves are divided into two. Now your turn. Mechanical waves are divided into two. Your turn. Y'all tell me. What are the two types?
Transverse wave and longitudinal wave.
Alright. Transverse wave and longitudinal wave. Write down. And mechanical waves are divided into two. Write down the two. Transverse wave, longitudinal wave. If you want to write it. Transverse wave, longitudinal wave. Right. First going to transverse wave. Tell me transverse wave. What's the keyword?
Perpendicular.
Perpendicular.
Perpendicular. Now make it into a sentence. What is transverse wave? What is
What?
perpendicular to what? Now think. Wait, I'll explain. What is perpendicular to what? Transverse wave. Transverse wave. What is perpendicular to what? See, particles are there. Let's take wave is traveling in this direction. That's the direction of propagation of the wave or direction of motion of the wave. Particles are going to move perpendicular. That's the direction of motion of the particles. Direction of motion of particles. Wave is that direction, particles that direction, they are perpendicular. Now put it into a nice sentence. What is transverse wave? If the direction of the wave is perpendicular to the direction of motion of particles, it is transverse wave. Again, look at the words I'm using. If the direction of the wave is perpendicular to the direction of motion of the particles, transverse wave. Agree? Yes.
Yes, sir.
Under transverse wave, let's write down. Under transverse wave, let's write down. If the direction of the wave is if the direction of the wave is perpendicular to the perpendicular to the perpendicular to the direction of motion of particles, direction of motion of particles, it is transverse wave. It is transverse wave. Huh. Tell me some examples.
Motion of a plucked guitar string.
Water
Wave.
Water wave.
of a plucked guitar.
So
Right on.
basically, tsunami is also a transverse wave, right?
Yeah, Buddha. All type of water waves are transverse waves. Tsunami wave, tidal waves, you can tell sea waves, all those. All water waves.
Earthquake.
Water wave, motion of a plucked guitar string. Even though I mentioned guitar string, it is not only limited to guitar string. Any string. Right. Now, very important point. Remember, transverse wave only propagates in solid and liquid medium. Can it propagate in gaseous medium? No. Only in solid and liquid medium it can propagate. Solid means mainly through strings. Solids like strings and through liquid. Now water wave is liquid. Solids and liquid only transverse wave can propagate. Through gaseous medium, transverse wave do not propagate. That point is given to you. Underline, highlight it. Propagate along solid and liquid or along strings and wires, not through gases. After that, a box is given. In that box, I want you all to draw this. Nicely draw it. Properly mention it is perpendicular. Done. Once done, tell me done. Right. Perfect. Now, we have a small activity to understand about wave motion. We have a small activity to understand about transverse wave motion. Usually, to learn about wave motion, we use a special setup called as slinky. Slinky. That is what we use to learn about wave motion. It's actually a spring. Slinky is a spring. Using that, you can learn about wave motion. I'll show you all a slinky. Now, this is a slinky. This is a slinky. It's actually a spring. This is a slinky. See? It's a spring. It's a spring. Sorry? It's a spring. Using that, you can learn about wave motion or you can sit and play. Right? Now, you can actually represent a transverse wave using a slinky. How? You take a table. I'll not do it on table, but you take a table. On the table, keep the slinky. On the table, keep the slinky. The other end of the slinky, attach it to the corner of the table. Now let's take my hand is the table. You keep it like this. The other end, you attach it to the table. Now you move the slinky this way, to the left and the right. You move the slinky to the left and the right. Bit hard. You move the slinky to the left and the right. Mehema, you move it. That will show us transverse wave. If I show to you all, it is something like this. It moves like this. This is a activity that is used to understand about transverse wave. See? And right. Transverse wave. If you want, you can tie some ribbons at several places. You can tie some ribbons. Then you can see nicely this slinky going up and down like this. Like that. You can nicely see. You can see that. Using a slinky, you can learn about transverse wave. Okay. That same activity is given there. Just needed a slinky, few pieces of ribbon. Tie pieces of ribbon at several places on the slinky. Place the slinky on a table as shown in the activity. Take it left and right to the plane of the paper. Observe how each of the ribbons move. So when you move it, it nicely moves like that. That's the direction of the wave. That's how you move the slinky. Understood the practical?
So then wave is not a straight line.
Perfect. Finally,
Excuse me, sir.
sorry,
So wave is not a straight line then.
sorry.
So wave is not a straight line. It's more in that design.
You're not clear, Buddha.
So wave is not a straight line then.
No, you can't tell something like that. Wave's direction can be represented using a straight line. Wave is a oscillation. Wave is a oscillation. So direction is straight line. Wave's direction is a straight line. Wave is a oscillation. Then we learn the physical quantities, you will understand more about how the wave is going to take place.
Thank you, sir.
Okay. Right. Now listen. Very important section. Transverse wave. Transverse wave. If I represent it, if I represent it, let's take wave is traveling in that direction. That's the direction in which wave is traveling. That's the direction in which wave is traveling. Particles are going to move perpendicular to the direction of motion of the wave. Particles move perpendicular now. In this case, particles are moving up and down. Now listen, very important points. Remember, in a wave, the highest point is called as crest. Highest point in a wave is called as crest. Then how many crests are there? 1, 2, 3. 3 crests are there in this wave motion. And lowest point in the wave is called as trough. Lowest point, trough. How many troughs are there in this wave? 1, 2. Highest points are crests. Lowest points are trough. Next, if you consider the particle motion, see, in this wave, each and every point you will have particles. Each and every point you will have particles. Particles are only moving up and down. Each and every point you have particles. What's the direction the particles are going to move? Now listen. Particles here. Particles here. They will try to drag the wave downwards. Particles here will try to drag the wave downwards. Particles here will try to drag the wave upwards. Particles there will try to drag the wave upwards. Particles here will try to drag the wave down. Here moves up. This part down. This part up. This part down. Now practically think. This part of the wave, they are trying to drag down. This part of the wave is trying to go up. Then next second, what will happen to the wave? Wave will come down. Wave comes down. This goes up. This comes down. This goes up. This comes down. This goes up. Like that. Next, this part up, next part comes down. That way, wave will move up and down. Wave will move up and down. Why? Particles are trying to drag this wave down, this wave up, this wave down, this part up. So particles are trying to drag the wave. Due to that dragging, wave is going to have a motion. That's how wave will continue its motion. That's how wave will continue its motion. So that point also keep in mind. How the particles are trying to drag the wave. That same picture is given to you all. That same picture is given to you all. That's here. This is the one. See? Here particles are dragging the wave down. If I slowly do, this part comes down, this part goes up. This part down, this part up. Here it goes. Next second, it's further move down, further move up, further move down, further move up. Next second, this wave is fully down, that wave up. This wave down, that wave up. That way, wave will change its motion. That way, wave will change its motion. If I show it using the slinky, see? Look. When particles go up, next they try to drag it down. They go up, they try to drag it down. They go up, they try to drag it down. That's how the full wave will propagate. That's how the full wave propagates. Okay. That's it. Transverse wave done. Next going to longitudinal wave. Next going to longitudinal wave. You all know. Tell me. Longitudinal wave. What's the keyword? What's the keyword?
Parallel.
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 Definition then. What is longitudinal wave? What is parallel to what?
Particles are parallel to the direction of the motion of
direction
the
of
wave.
Particle motion is parallel to the direction of propagation of the wave or direction of motion of the wave. So if I properly explain it, what is longitudinal wave? What is longitudinal wave? What is this longitudinal wave? Let's say wave is traveling in this direction. Then particles are going to move front and back, front and back, front and back. This way particles are going to move front and back, front and back. That means direction of motion of particles, direction of motion of particles are going to be parallel to the direction of motion of the wave. Particles motion direction is parallel to the motion of the wave, direction of motion of the wave. So putting them into a sentence, what is longitudinal wave? If the direction of motion of the wave is parallel to the direction of motion of the particles, it is longitudinal wave. If the direction of motion of the wave is parallel to the direction of motion of particles, longitudinal wave. Okay? That's right. Under longitudinal wave, if the direction of motion of the wave, if the direction of motion of the wave if the direction of motion of the wave is parallel to the is parallel to the is parallel to the is parallel to the Direction of motion of particles. Direction of motion of particles. Direction of motion of particles. It is longitudinal wave. It is longitudinal wave. It is longitudinal wave. Again, see, if the direction of motion of the wave, if the direction of motion of the wave is parallel to the direction of motion of particles, it is longitudinal wave. That's a good question. Sir, should we memorize the definition? All just tell me now, according to the way I have taught you all, is it really needed to memorize the definition? Is it really needed to memorize, separately sit and memorize the definition? No need. Now, understand the logic there. That's what is most important in science. Now, transverse wave, perpendicular. That's the keyword. Particle motion perpendicular to the wave motion. Longitudinal wave, keyword is parallel. Particle motion parallel to the wave motion. So, understand the key, understand the logic, know the keyword. From that, you will build the definition. Don't go to memorize the definition. Don't memorize the definition. Okay. That is what is most important in science. Don't go to memorize definitions. You understand the definition, understand the logic, then you put your own words and you can make the definition. I guess the definition I am giving, it's not the exact words I have in the textbook, because I have not memorized the textbook. I have understood the definition in it. Once you understand the definition, you write a definition like that. Maybe your definition is more perfect than the real definition. But what is important is you have to understand the definition. You have to understand the logic there. Then you apply it and write. Example. Tell me, what's the example? Longitudinal wave. What's the example we have?
Sound wave.
Sound wave.
Sound wave. Write down. Sound wave. Now, very important point. Listen. Remember, these longitudinal waves can propagate to solid, liquid, as well as gases. Through solid medium also it can propagate. Through liquid medium also it can propagate. Through gaseous medium also it can propagate. Through all those three medium, this longitudinal wave can propagate. But transverse wave, can you all remember, can it propagate through gaseous medium?
No.
No. Only in liquid and solid.
Transverse wave can't propagate through gaseous medium. But longitudinal wave, they can propagate through gaseous medium. Okay. Underline or highlight this part, propagate through solid, liquid, and gases. And then in that box, draw this. I'll keep a ruler and nicely draw, right? Done. Okay. Right. Now, to understand this also, we have an activity with the slinky. You take the slinky, keep it on a table. You take the slinky, keep it on a table. Now, I'm going to move the slinky forward and backwards. I keep it on a table and move it forward and backwards. Think. When I move it forward and backwards, look very carefully. Look at those bunches going. Eh? Can you see wave is traveling from here to here? Wave is traveling from here to here. That direction wave is traveling. But particles are moving forward and backward. See? Look how I'm moving my hand. I'm moving it forward and backwards. Particles are moving forward and backwards. Wave is traveling from here to here. Particles are moving forward and backwards. Particles are moving forward and back, forward and backward. What wave? Longitudinal wave. If you want to clearly see, you can tie some ribbons. Then you can perfectly see particles moving forward and backwards. Particles moving forward and backwards. And one more special point. When I move it forward, see, I am compressing them together. I am compressing them together. I'll slowly do. I am compressing and releasing. When I move it forward, I am compressing. That creates a compression. When I move it forward, I create a compression. See, when I move it forward, I create a compression, 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 compression. And when I move it backward, I am creating some spaces between these bunches. I'm creating some spaces. Those spaces are called as rarefaction. This is compression. This is rarefaction. Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. That is how longitudinal wave propagates. We create compression, rarefaction. Compression, rarefaction. Look at the spring. Rarefaction. Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. That's how the wave propagates. If I draw and show you all, let's take, this is the normal slinky. When I move it forward, compression. And when I move it backwards, rarefaction. And this is the normal slinky. These are compressions. These are rarefaction. Rarefaction is when the slinky gets spaced apart. So longitudinal waves also propagate, creating compressions and rarefaction. Compression, rarefaction, compression, rarefaction. That's how wave propagates. Okay. Understood this compression rarefaction part? If you want, I'll show you all one. See? Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. Compression, rarefaction. Ah, take the tube. Activity 2.3. Apparatus slinky, a piece of ribbon. Place the slinky on a table and fix one end. Tie ribbons on one coil and move the free ends of the slinky forward and backward as shown in the figure. When the free end is pushed forward, the coils near the end are bunched up. This is called compression. When the free end is pulled backwards, stretch. This is called rarefaction. See, a bunch up, compression. They space apart, rarefaction. Okay. Next, we know example for transverse wave is sound wave. Example for transverse wave is sound wave. Some important points about sound wave. It's a longitudinal wave, sorry. It's a longitudinal wave. Example for longitudinal wave is sound wave. Now some special points about sound wave. We have something called tuning fork. We have something called tuning fork. Tuning fork. Have you ever seen tuning forks? Music students, you should have surely seen tuning forks. Have you seen tuning fork? These tuning forks. These are tuning forks. One of those are not seen. These are tuning forks. These are tuning forks. You hold it from the stem here, this bottom part. It's called the stem. You hold it from the stem. And you hit it on a rubber stamp. On some rubber thing, you hit it. I don't have any rubber here. No, we have. You take the tuning fork, you hold it like this. You hit it on a rubber thing. When you hit it, it produces that tin, that kind of sound. I don't know whether my mic will catch up. I'll try to take it to the mic, see whether you all can hear. No, I don't think you all can hear. However, when you hit it, I can hear it. It produces a tin sound. I'll use my phone mic. Can you hear? I'll use another one. This is a smaller tuning fork. Keep your volume full. That's a tuning fork. That's not the activity. Activity is this. To sound a tuning fork, when you touch it with your finger, you will see a vibration. I don't know whether you can see properly. I'll bring it very closer. Can you see it's vibrating? When you touch it, you can feel a nice vibration there. It's a forward and backward motion. It's a forward and backward motion. You can feel it with your finger. When you touch it with your finger, you can feel a forward and backward motion. What does this tell us? It's actually a vibration. That forward and backward motion is a vibration. That vibration only produces that sound. That sound comes from that vibration, that forward and backward motion. So that means sound is produced by vibration. Sound is produced by vibration. When you touch the tuning fork, after sounding it, you can feel there is a forward and backward motion. Forward and backward motion is the vibration. That's a small activity we have. Okay. Sound a tuning fork and touch the end of its two arms with your finger. With your fingertip. You will sense a small vibration in your fingertip. The reason for this is alternate contacts and removal of contact of the tuning fork arm with your finger. The back and forth motions in the arms of the tuning fork are known as vibration. We can hear sound through the waves generated by such vibration. Sound waves that cause sensation of hearing are known as sound waves. Such waves that cause sensation of hearing are known as sound waves. Sound waves generated in air is another example for longitudinal wave. It's a longitudinal wave. Okay. Finally, difference between transverse wave, differences and the similarities between transverse wave and longitudinal wave. What are the similarities and differences between transverse and longitudinal waves? What are the similarities and differences between transverse and longitudinal waves? Transverse and longitudinal waves, both are mechanical waves. If both are mechanical waves, they need a medium to travel on. Require a medium. Require a medium. Longitudinal wave also require a medium. Medium is a requirement. That is a similarity. Next, transverse wave. What's the keyword? Perpendicular. Motion, I'll write it in short. Motion of particles perpendicular to wave. Motion of particle perpendicular to wave. But longitudinal wave, what's the keyword? Parallel. Motion of particles parallel to wave. Finally, transverse wave propagates through solid and liquid, not through gases. Propagate through solid and liquid. What about longitudinal? Solid, liquid, and gas. Propagate through solid, liquid, and gas. Right now. Yes, first one is same for both. It's a similarity. Done. What's the use of tuning fork? The main use of tuning fork in music is it is used to tune musical instruments. But nowadays we don't use tuning fork to tune musical instrument. We can use now there are apps now. If it is a guitar, you can use guitar tuner. Like that, there are electronic tuners also. The main real use of tuning fork is to tune musical instruments. In science course, to learn about waves. In A level, you'll have to learn about sound waves, uh, how the wave is formed inside a tube. There are experiments for those. Those things you tune that basically produces a sound of a required frequency. Now, this is a set of tuning fork. Each tuning fork has a certain frequency. Now, the longest one, its frequency level is 256 hertz. Longest one. This short one, its frequency is 512 hertz. Small one is double the longer one. That's how it is. Longer one is 256. Shorter one is 512. In between them, you have a frequency range. So according to what frequency you want, you can select it and you can do it. Harined. That's something additional for you. Right. That's it. Transverse wave, longitudinal wave, initial things are fully done. Fully done. Next, going to very important section in this lesson. The most important section in this lesson. All sit properly. All sit properly. Look very carefully. On physical quantities associated with wave motion. Physical quantities associated with wave motion. Listen very, very carefully. Right. Physical quantities associated with wave motion. Lamai, there are two physical quantities that shows regular variation with the wave. One, distance wave travels based on displacement of the particles. Two, time taken for the propagation of the wave based on the displacement of the particles. Initially, you understand. Once you will understand. So first, just listen. There is with and displacement in the wave. Two, there is a variation with time and displacement of the wave. First, we will talk about displacement and distance variation. Listen very carefully. First, we will talk about displacement and distance variation. I'll draw a graph to explain this. That's my y-axis. We'll take y-axis as displacement of the particles, displacement axis. That's the x-axis. I'll take the x-axis as distance that the wave is traveling. Displacement of the particles, distance that the wave is traveling. First, look very carefully. I'll draw a typical wave. That's a wave. That's a wave. Down part is a bit short. That's a wave. On. In the wave, what are the important physical quantities? Listen very, very carefully. Lamai, I start from here. Go up, come down, go up again. That is one single wave. That is one wave. This is one wave. This is one wave. Then looking at this, tell me altogether how many waves are there in this diagram, in this graph? Altogether, how many waves are there? Count and tell me. Three waves are there. 1, 2, 3. Three waves are there. 1, 2, 3. Right. Next point. Listen very carefully. The highest point in the wave is called as crest. Highest point is crest. Then altogether, how many crests are there? 1, 2, 3, 4. 4 crests are there. 1, 2, 3, 4. 4 crests. Next, lowest point in the wave is called as a trough. Lowest point in the trough. Then altogether, how many troughs are there? Altogether, how many troughs are there? 1, 2, 3. 3 troughs are there. 4 crests are there. 3 troughs are there. 3 troughs are there. Next point. Listen very, very carefully. Next point. Maximum displacement of the particle taking part in the wave. Maximum displacement of the particle taking part in the wave. Maximum displacement kya? If you take the particle, its maximum displacement is this. Maximum displacement of the particle taking part in the wave. And that maximum displacement is called as amplitude. What is the maximum displacement called as? Amplitude. Even it can be written from this side. Even that can be amplitude. Here the amplitude and here the amplitude are going to be equal. If it is changing, they will tell that. Here the amplitude are equal. Maximum displacement of the particle taking part in the wave. Amplitude. I'll give you all two waves. Wave 1. Wave 2. Which one amplitude is very high? Wave 1 or wave 2? Which wave's amplitude is very high? 1 or 2?
Wave 2.
Wave 2.
Right.
Wave 2.
Again.
Wave 2.
Wave 2. Second.
Wave 2.
So amplitude is the maximum displacement of the particle. Maximum displacement of the particle is amplitude. Next point. Length of one single wave. Length of one single wave. That means now this is a wave. Length of that wave. This is the length. This is one single wave. This is the length of that wave. Length of one single wave is called as wavelength. Length of one single wave is wavelength. We represent wavelength using a Greek symbol. This is the symbol. This is the symbol for wavelength. It's like I written on other side. In Greek language, you call it lambda. Actually, in science, we come across a lot of Greek letters. Alpha, beta, gamma, theta, mu, phi, lambda. Now some of you all are wondering why suddenly is talking Japanese. Japanese name. This is Greek symbols. In science and maths also, we come across a lot of Greek symbols like this. So this is lambda. Lambda. Lambda is used to represent wavelength. Lambda is used to represent wavelength. So what is wavelength? Length of one single wave. Length of one single wave. Wavelength. On. Which one's wavelength is long? Which one's wavelength is long?
First wave one.
Wave
Wave one.
First term. See, length of one single wave, this length. Here the wavelength, this much. One single wave, you consider one single wave, this length. That length is short. Okay. Another one. Now think and answer. I'll mark this as displacement. X-axis as distance. This is 4 meters. Think and answer. 4 meters. Question. What is the wavelength of this wave? What is the wavelength? What's the wavelength of this wave? Think and answer.
2 meters.
2 meters. 2 meters.
2 meters.
Perfect. See, I have given for 2 waves. 1, 2. 2 waves, 4 meters. 2 waves, 4 meters. Then 1 wave, 2 meters. The length of one wave is 2 meters. Length of one wave is 2 meters. Then wavelength is 2 meters. Wavelength is 2 meters. 2 waves 4 meters. Then 1 wave 2 meters. Then wavelength is 2 meters. Okay. Another one. Mathematically think and answer. Displacement versus distance. Mathematically think and answer. What's the wavelength?
1 meter.
1 meter.
1 meter.
1.2.
You're a good
1
knowing.
meter.
1
Y'all
meter.
can do the exam actually. There's nothing to teach y'all. I can do the whole exam. Now this whole exam, most of the section came from grade 10. Again, most of the section means we can tell 55% came from grade 10. And y'all are in your grade third lesson done, no? Fourth lesson. Good. Now the logic is this. I have nothing to teach now. I think you all are told no. The logic is this. Count the number of waves. One wave is there. two wave is there, full wave, and a half of a wave is there. One, two wave, two and a half. One wave, two a wave, two and a half wave is there. Two and a half wave, 2.5 meters. Two and a half wave, 2.5 meters. Then you break it. See. Two and a half wave, 2.5 meters. One wave, how many meters? Two and a half wave, 2.5 meters. We'll break it into half waves and discuss. Two and a half wave, 2.5 meters. Then half of a wave, how many meters? 0.5 meters, neither. 0.5, 0.5, 1 meter. Another 0.5, 0.5, 2 meter. Another 0.5, 2.5 meter. Half of a wave, 0.5. 0.5, 0.5, 1 meter. 0.5, 0.5, 1 meter, 2 meter. Another 0.5, 2.5 meter. Then half of a meter is 0.5 meter. Half of a wave is 0.5 meter. Then full wave, how many meters? 1 meter. This is 1 meter. This is 1 meter. This is 0.5 meters. That's how 2.5 meters came. Understood this wavelength story?
Yes, sir.
Yes. Perfect. That is wavelength. But definition is given in a slightly different way. Wavelength definition, you don't give it as length of a wave. It's given in a slightly different way. What's the correct definition of wavelength? The distance between a particle in the wave and closest next particle that shows the same state of motion. The distance between a particle in the wave and closest next particle that shows the same state of motion. That means, see, if I take a particle here, I'll take a particle here. The distance between a particle in the wave and closest next particle that shows the same state of motion. Same state of motion. Now think, this particle and this particle, are they in the same state of motion?
No.
Yes or no? No.
No.
This particle and this particle, are they in the same state of motion?
No.
This particle and this particle, are they in the same state of motion?
No.
No. This particle and this particle, now you will tell yes, no. This particle, it's in the upward part of the wave. This particle is it's in the downward part of the wave. They are not in the same state of motion. Only half of the wave is completed. They are not in the same state of motion. This particle and this particle, are they in the same state?
No.
This particle and this, are they in the same state?
No.
This?
No.
But look at this. This and this, are they in the same state of motion?
Yes.
Length between them, that is wavelength. That's how you define wavelength. Distance between a particle in the wave and closest next particle that shows the same state of a particle in the wave and closest next particle that shows the same state of motion. Even it can come like this. You have a crest, the closest next crest. Crest, closest next crest. Look at that length. Look at that length. You're starting from here, going down, fully going down, coming up. That is also wavelength, neither. This particle and this particle, same state of motion. This and this, same state of motion. Crest and crest. That length is also wavelength. Trough and trough. Consider trough and trough. Same state of motion. That length is also wavelength. So even wavelength can be defined as length between two consecutive crests. Two consecutive crests, wavelength. Or two consecutive troughs, wavelength. All those things are wavelength. So basically put to the mind as length of a wave. Now take physical quantities associated with wave motion. Don't look at this graph. I'll come to those graphs under that. Crest, maximum point of a wave. Trough, minimum point of a wave. Amplitude, maximum displacement shown by the particle taking part in the wave. Wavelength, distance between one particle and closest next particle taking part in the wave motion having the same state of motion is known as wavelength, lambda. Or it can be told as distance between these two particles, that is the distance between two consecutive troughs or crest, is equal to wavelength. Consecutive crest or trough. Now those things I explain by using graph drawn for displacement and distance. I drew this graph for displacement and distance. Now I'm going to draw a graph Now I'm going to draw a graph for displacement for displacement and time. Now the graph is for displacement and time. Nothing to worry, just look. Most of the things are the same. Onnabuta, this is one single wave. That is one single wave. One wave. Maximum point in the wave is crest. Minimum point in the wave is trough. Maximum displacement of the particle is amplitude. Maximum displacement amplitude. That is amplitude. Now, my x-axis is time. It's not a length measurement. Before, my x-axis was distance. It was a length measurement. We define wavelength here. Now, my x-axis is time. It's time now. It's not length measurement. On. Now see, we define something called period. Period time. Period time is defined as capital T. Period time is capital T. What is period mean? Time taken for one wave. Wave is also called as oscillation. So we can tell time taken for one single oscillation is period. Time taken for one single wave or one single oscillation is period. That means, see, this is one wave. I'll mark the time there. Let's say you start from T naught. This is T1. This is T2. This is T3. This is T4. Now check. Time taken for one wave. Time taken for one wave. How much of time is taken for one wave? T4 time is taken. That's the period. Right. Maybe 5 seconds, 10 seconds, 20 seconds. How much of time is taken? Time taken for one wave. Time taken for one wave or time taken for one oscillation. Time taken for one wave, or you call it time taken for one oscillation. That is period. That's period. If I give you all an example, this is one. Displacement versus time graph. Let's take the time here is 4 seconds. Then what's the period here? Period is time taken for one wave. One wave, 4 seconds is taken. 4 seconds is the period. Okay. Now your turn. Displacement versus time graph. This is 4 seconds. Think and answer me. Eh? That is 4 seconds. What is the period?
2 seconds.
Think in terms of definition.
2
Yes.
seconds.
Think in
2
terms of
seconds.
definition. Time taken
2
for one wave.
seconds. 2 seconds.
Very good. See? 2 waves, 4 seconds. Period is time taken for one wave. Then one wave, how many seconds?
2 seconds.
2 waves, 4 seconds. Now, one wave, 2 seconds. 2 waves, 4 seconds. Then one wave, 2 seconds. That's the period. Okay. Another one. Displacement versus time graph. Mathematically think and answer. Mathematically think and answer. What's the period?
Four seconds.
3.6.
You are getting decimal answers. Now I'll make it more easier. Then I'll make the question tough. Wait, we'll make it I'll make it 15 seconds. Now easy.
6.
6 seconds.
7 seconds.
6 seconds.
6 seconds.
6
seconds.
6 seconds.
This how you do deal it. See, how many waves are there? 1, 2, 2.5. Are halves is there? No? That's a problem. No? I'll break it into halves. 1 half, 2 half, 3 half, 4 half, 5 halves are there, isn't it? 5 halves are there. 15 seconds for 5 half. 15 seconds for 5 half. 15 seconds for 5 half kiyanne. For 1 half, how many seconds? For
3 seconds.
1 half.
3 seconds.
3 seconds. 1 half, 3 seconds. 1, 2, 3, 4, 5. 5 halves, 15 seconds. Then 1 half, 3 seconds. 1 half, 3 seconds means 2 halves. That is
3
one full wave. How many seconds?
6 seconds.
6 seconds.
This is 3 seconds. This is another 3 seconds. Altogether how many seconds? 6 seconds. 6 seconds. So period 6 seconds. Arine? 3 seconds, 3 seconds, 6. Another 3, 3, 12. Another 3, 15. So half of the wave, 3 seconds. Then one full wave, 6 seconds. Okay. Y'all want to try another question like that?
Yes, sir.
We'll do
Yes.
another one. Displacement versus time. Hmm. What's the period?
10 seconds.
10 seconds.
10
10
seconds.
seconds.
10 seconds.
10 seconds.
10 seconds.
Perfect. I'll count the halves and do 1 half, 2 half, 3 half. 3 halves are there. 15 seconds for 3 half. Then 1 half, how many seconds?
5 seconds.
5 seconds. 15 seconds for 3 half. Then 1 half, 3 seconds. 1 half is 5 seconds. Then 2 halves, another 5 seconds. Altogether, how many seconds?
10 seconds.
10 seconds. Altogether 10 seconds. Okay. Understood this period now? Period time.
Yes, sir.
How much of time taken for one oscillation, or how much of time taken for one wave. With that, I'll teach another small part. With that, another small part. Frequency. Frequency. Frequency is the opposite of period. That means, now what is period, Lamai? Just now we discussed. What is period? What is period?
Time taken.
Number of
Time taken
oscillations.
for single wave.
Number of oscillations. Number of oscillations is 1. For one wave, how much of time taken? For one wave, how much time taken? One wave, how much time taken? That is period, no? 10 seconds, 20 seconds, 5 seconds. How much time taken for one wave? That is period. Frequency is the opposite. In 1 second, now time is becoming 1. How many waves are there? Or how many oscillations are there? In 1 second, how many waves? Frequency. One wave, how much time? That is period. Now opposite. 1 second, how many waves? That's period. In 1 second, in a unit time, how many oscillations are taking place? Number of oscillations in a unit time. Number of oscillations in a unit time is frequency. That means one second. How many oscillations are there? How many waves are there?
2.
Then we tell frequency of this wave is 2 hertz. In 1 second, 2 waves are there, then the frequency is 2 hertz. Okay, again see, what is frequency? Number of oscillations in unit time. In simple terms, how many waves are taking place in 1 second? Opposite of period. Period is how much time taken for one wave. Time for one wave is period. 1 second, how many waves is frequency? 1 second, how many waves? 2 waves. Then frequency is 2 hertz. With that, I can give one more point. What's the SI unit of frequency? SI unit of frequency is hertz.
Hertz.
Another unit is also. The other unit for frequency is per second. S to the power minus 1. The other unit is per second. Again, one more time, see. Again, one more time, see. This is very important. Frequency and period. Period. Time taken for one wave. Period. Again, repeat with me. Time taken for one wave period. Frequency, number of waves in 1 second. Or in more better, number of oscillations in unit time. Frequency. Number of oscillations in unit time. In 1 second, how many oscillations are there? There are 2 oscillations, then frequency is 2 hertz. If there is 1 oscillation, frequency is 1 hertz. SI unit for frequency is hertz. Another unit, s to the power minus 1 per second. Okay. What's the relationship between frequency and period? What's the relationship between frequency and period? See, can you see? Period is the opposite of frequency. Period is the opposite of frequency. If I write it mathematically, period is the reciprocal of frequency. Period is the reciprocal of frequency. So in other term, you can tell frequency is the reciprocal of period. Frequency is the reciprocal of period. Is equal to 1 over period. Or even you can write it the other way. Period is equal to 1 over frequency. Put this up, put this down. So they have opposite connection. Frequency is the reciprocal of period, or period is the reciprocal of frequency. It's a reciprocal. Reciprocal is connected. Reciprocal is connected. Okay.
Excuse me, sir.
Yeah.
Can you show it from numbers? I mean,
Sorry.
can you show it how it comes?
The amplitude part.
No. The frequency and the,
The reciprocal part.
yes.
Okay, I'll give time to write. I'll give time to write. Don't worry. I wanted to give you all one more point. Give you all 2 waves. Wave 1, wave 2. Wave 1. 2 waves are there in 1 second. 2 waves in 1 second. Wave 2. I don't know how many waves. This much of waves in 1 second. 2 waves in 1 second. This much of waves in 1 second. Which one's frequency is highest?
Wave 2.
Wave 2.
Which one's frequency high?
Wave 2.
And no, right. Second one. Why? Number of oscillations in unit time is high. Lot of oscillations are there in unit time. In 1 second, lot of oscillations here. Here only 2 oscillations. Here lot of oscillations in unit time, which means frequency is high. Here only 2 oscillations in unit time, frequency is low. Okay. Now come to the tube. Period. Time taken by a particle to complete oscillation. A oscillation is known as period. To complete by particle for a complete oscillation is known as period. Time taken by particle for a complete oscillation is period. Symbolized as capital T. Frequency. Number of oscillations carried out by the particle in a unit time is known as frequency. Frequency is equal to the reciprocal of period. The unit used to measure frequency is known as hertz, and 1 hertz is defined as 1 oscillation per second. Under that, a box is given. Write the equation. Frequency is equal to 1 over period. Reciprocal of the period. Right. Last part. Speed. Speed of a wave. Now my waves have a certain speed. It travels at a certain speed. How to calculate that speed? How to calculate that speed? We have an equation. Speed symbolized as v. Speed of is equal to frequency multiplied by wavelength. V equal f lambda. Speed of a wave v is equal to frequency wavelength lambda. V equal f lambda. V equal f lambda. You multiply frequency by lambda, you get the speed of wave. Huh? Another speed section, write it. So what's the SI unit of wavelength? Try to think. Wave
Meters.
length is measured in what? Meters. SI unit is meters. So wavelength, SI unit is meters. Okay. How did that reciprocal part come? Reciprocal, think of the definition. Frequency is number of oscillations in unit time. Period is time taken for one full oscillation. So it's the opposite connection. That's why we tell frequency is the reciprocal of period. It's the opposite connection. Okay. Wrote the equation for speed. What's the unit for the speed of the wave? Try to think. These things you all know. Speed, what's the unit?
Meters per second.
Meters per second. Meters per second is the unit. Don't worry. We'll be solving some questions from this equation next week. You don't like equation? Next week, we'll be solving some equations or questions from that equation. That part we'll be doing next week. That's there for next week. So with that, first part of waves is done and physical quantities is done. What do you all think? I hope this is the first time you're learning. Most of you are not done in the school. Do you think you all understood the sections?
Yes,
Yes.
sir.
Yes, sir.
Yeah, sir.
Okay, with the section. Very good.
Thank you, sir. Thank you, sir.
Thank you so much, sir.
Thank you.
Thank you, sir.
Thank
Next week
you,
also
sir.
y'all have the free session. So next week we'll be finishing the equation. We call F lambda equation questions. Some questions are there. I want to finish those questions. And then we'll be doing electromagnetic waves. Today we didn't touch electromagnetic waves. No? Only mechanical waves were done for today. So next week we'll be touching the electromagnetic waves as well. So with next week electromagnetic waves will be done and we'll be starting sound. Okay. Yeah, next week is also a free session. And after that, we'll be shifting to the normal paid session. The normal paid session, the fees is 2,000 per month. It's the normal fees that we have in all the classes. That's the normal fees amount. And after that, every Saturday night from 8 to 10:30, we'll be proceeding like this. Allowing you all to unmute and talk. My win. It's not a live stream of the physical class. Now, those who join our physical class, they can feel the difference now. More than physical class and interactive class, the difference there. Physical class, it's mainly the physical students focused. Interactive class, it's mainly y'all, only y'all focus. Y'all can unmute and you can talk and y'all can ask the doubts and go, right? And later on, this will be integrated at the end of the session. Now today actually, 10:30, I have to go to candy now. Right? Tomorrow morning classes there. Now I have to go to candy. Right? After the class, we have to now travel to candy. So later on, so slowly we will be having now after 10:30 today 10:30 sir now which I'm going later on I'll be going in the morning. එතකොට after 10:30 I'll be giving you a separate time to unmute and ask doubts and solve everything for that day and go. එහෙම will be slowly proceeding. Okay, that's the thing. That's the plan, right? And it will proceed until your O level like this, starting from the waves lesson until the last lesson, until biosphere section. Okay then, keep working. I'll meet you all again next week. Bye.
Excuse me, sir.
Yes, Putha.
Will you upload any videos on the third lesson, sir?
Third lesson is actually done. So far, no any plans of uploading any videos. Okay.
Excuse me, sir.
Okay. Yeah. Wait a
Sir,
minute,
will
Putha.
you
I'll
leave?
stop the live stream, YouTube live stream.
Okay.